In this video, we will be taking a look at Esri's utility network management for ArcGIS, focusing on analytics of the utility network, which includes tracing and schematic diagrams. We will be showing how to configure different types of traces to better understand our network, and how we can generate schematic diagrams to obtain a simpler view of our data. My name is Megan Cheong, and I am part of the GIS Technical Solutions team based in Wellington. Let's begin by covering tracing and its purposes in the utility network. A trace is an important part of network management because it provides a framework in which utilities can use network data to derive business value. Tracing can help with answering questions about the current state of the network as well as plan for future developments. Questions such as, which valves need to be shut off to isolate a water leak at this location? How many houses are fed by this transformer? And can the device handle more connections? If these customers lose power during a storm event, what devices upstream could have been tripped? How does a trace work? A trace begins at one or more starting points or at the subnetwork controller or source for the specified subnetwork and propagates outward. The trace ends when it encounters the end of the path or a specified barrier. Barriers define locations at which the traversal of a trace terminates. Upon completion of a trace, the results are returned in the form of a selection set of highlighted features, which can then be inputted into a reporting function. For example, to send out notices to affected customers for planned outages, or the results could be propagated into a schematic diagram view, as you'll see in the demo. In ArcGIS Pro, there is a gallery of trace tools to choose from to meet your business needs. Tracing depends on a validated network topology, which is why when making edits, it is important to validate the topology and update the subnetwork to reflect the most recent updates to the utility network. Let's talk through a few different types of traces. A connected trace finds all features that are connected to a given set of starting points. It is useful for validating newly edited features that are connected and participating in the network. A subnetwork trace discovers features that are participating in a subnetwork. It will trace from the starting point until it finds a subnetwork controller, an end of path, or a feature that is not traversable, like the open switch in the diagram. A subnetwork controller trace, like its name suggests, identifies the subnetwork controller of the subnetwork. An upstream trace finds features upstream from the starting points to the subnetwork controller. A downstream trace finds features from the starting point that are away from the subnetwork controller. Network diagrams are a symbolic representation of geographic information drawn using pre-canned algorithms. Also known as schematics, these diagrams show a simplified representation of your network to explain the network structure and the way it operates. These can be created by your users as a quick way to show logical views of sections or the result of a network trace. Diagrams can be stored and edited and saved inside the network, and they can be made available and secured for views of complex or critical operational portions of your network, like a substation. There are a number of tools available in ArcGIS Pro to create your diagram layouts, and you can edit white space to suit your particular situation. Let's get into a demo now. I have here some electric data opened up in ArcGIS Pro. This is a subset of network data from Network Waitaki, an electrical distributor based in North Otago in the South Island of New Zealand. We have an overhead transformer here, and we can see it has several connectivity associations with the surrounding features. Let's drop a starting point at this transformer and run a connected trace to confirm that electricity can flow through it and onto those surrounding features. So in the Trace tool pane, I'll make sure my electric utility network is selected and leave the default checked boxes as they are. I'll run the trace. The trace completes and shows all features that are connected to the transformer, which seems to be the entire network. Great, so it means electricity is flowing through as expected. Next, let's run a downstream trace from the same transformer, One use case could be we want to conduct maintenance on this transformer, so we need to figure out which houses or service connections are fed by it in order to send out outage announcements. We will leave the starting point in the same place, but select Downstream Trace option. This time, we need to specify that the domain network is electric. Because this demo data is configured within the electric distribution tier, I will select that for both the tier and target tier drop-down lists. But bear in mind that traces are able to run between tiers. In order for the trace results to show the service connections, we need to configure the asset type in the output section. So below here, we can choose a specific asset type, which will be both the low voltage single phase and low voltage 3-phase residential service connections. Okay, the trace executes, and we can now see the service connections highlighted on the map for us. There are 6 of them being fed by this transformer. Let's do an isolation trace next. For this, I'll just bring up some sample water network data from Naperville in the United States. An isolation trace helps to locate isolating features. I want to replace the length of pipe, so I need to know which valves I need to switch off in order to isolate the area. I've added my starting point to the work area. In the geoprocessing tool, I've selected the water network, the water system tier, and I need to just add a filter barrier to configure this trace. So I'll filter for the category to be isolating. I'll run the trace. The trace executes and returns the 2 valves that I need to turn off. Returning back to our electric data now, I've already run a connected trace starting from the circuit breaker in this substation and added a couple of barriers to constrain the trace extent. Using these results, we can generate a diagram to obtain a symbolic representation of our data. From an end-user perspective, we can go to the diagram group in the utility network ribbon and click New. So this will create a diagram based on the default basic template, which will appear in a new tab. As you can see, the map symbology has been applied. Now we can work with it. So to make the diagram a bit easier to read, we can choose a diagram layout to apply to it. There are many types, but I'll select the smart tree diagram, which is a hierarchical layout. I'll add a root junction to define where I want the smart tree to begin, and I'll make the edges curved. I'll apply the layout. And now we can see it started with the root and made some nice curves to show the network in a hierarchical manner. I'll dock it next to our map. You can see that we can propagate across the selection from the diagram to the map. We can also edit the white space around it. For instance, I can move this junction here if I feel that it's too crowded. And notice how we can access the same editing tools in the diagram that we have in the map, giving us that capability to edit these schematics. Now to store a diagram, we can click on the Store button, give it a name, and decide whether we want it to be public, protected, or private. Private is only viewable by whoever created it. If we don't choose to store it, because maybe we wanted a quick view of a section for reference, there are processes in the background that will purge those temporary diagrams, so you don't have to worry about needing to clean out unnecessary diagrams from your database. To retrieve stored diagrams, we can click on the Find button, and it will automatically find any stored diagrams that are within the extent of the map. So here's another diagram of the same trace results I had prepared earlier. This one uses the same smart tree layout, but instead of the basic template, it uses the electric distribution substation template. And you can see that there are differences. The transformers are surrounded by boxes, which represent the containers they're located within. And the features within the substation are also displayed inside the container. There are many different ways to visualize the layout of your features. So that was a quick summary of tracing and schematic diagrams, 2 analytical capabilities that help you better understand your utility network. That concludes this session. There is a lot more information that could be covered, but we hope this gives you a good overview of the key concepts regarding tracing and schematic diagrams. For any more information or questions about the content covered in this presentation, please contact us here at Eagle at the email address on screen, utilities@eagle.co.nz. Also, please stay tuned for upcoming videos on other aspects of utility network management for ArcGIS. Thank you for watching and have a great day.